haven't got a lot of space here, but you can see this vehicle is moving. When it sees this doll, it moves twice forward, like that. All the motors go. Alright. And then it stops. Okay? So if I move this away, it'll go off on a search pattern again. So it should be looking or turning to the right. Sorry. Doll's back. All motors. Oh yeah, there you go. Okay, it found me. Go looking again. And there's my video.
Hi everyone. So this is me earlier today. My version of that is this, my first test of the robot you're about to see. Oh.
Oh, wrong direction.
First,
Okay, okay, not working.
right. So I'm going to discuss how to build that. Now, before I get into how to build that, I will probably show you it working. So on the screen in front of me, we're going to start off, and you can see the robot there. Let's see if I can make it a bit bigger. Controls. So stretch it out a bit more. Okay. What you have in front of you is the HTML that's been hosted on the Arduino board here, okay, on an ESP. This is an Arduino tech, and you configure it by flicking the dip switches here. So for you would go to 5, 6, and 7 and turn off 1 and 2. Then start coding with the normal Arduino IDE, and then when you begin to start programming it, you have to hit the reset button, and then it codes afterwards. Okay, that's how you get the web page script on the ESP, which is what you see over there on the top. Now, then you go to turn off 5, 6, and 7. Then you go to 3 and 4. And you program that up with the normal Arduino code that would be, say, running the pins which are on 7, 8, 9, and 10. And you have the ground and the power connected up to common ground for each of the drivers. Now, this is a very basic robot overall. It's just controlling DC motors that are working with simple drivers, one direction. So nothing too fancy. What we're going to get into talking about is using L, which is the new way of writing, prompts as coding. So if prompts are coding, you can use vision from computer software to, from AI to act or do stuff for you. So it's like function calling, right? But I'm using the L framework. Now, all the code for this project is going to be in the description. So I'm just going to go through a little bit of it right now. So taking the mobile phone here, and we just look at this. I've got it balanced on something, so it doesn't run off the table. Hopefully no more mistakes. And I'm clicking the forward button. One motor there, next one, and next one. Okay? So 4 motors all running in the same direction. Okay? Now you can see I have a lot of battery packs because I have each motor running off of 4 different batteries. It can take up to 24 volts each, so these are actually underpowered for what we have here, but hey, it works. Now, let's just get into a little bit of the code before we go into the vision stuff, okay? So the ESP code, which you will find when you're coding it, go into, changes all the bloody time. So here's the Arduino code on the left here. So it's just quite simple. We're going to output on different pins for when we want to run out the ESP code, I think. Yes, this is the ESP code. Sorry. The reason for my confusion is, can I zoom in? The Arduino IDE forgets what board it was working with previously when you set up these things. and that's okay. Anyway, I got this plugged into COM port 3. You can trial and error. Now your board is going to be a little bit different, but basically you go down to Tools, Board, Board Manager, and you can search through the drivers to see if you have the correct driver for the board that you have. Check your manufacturers first. But otherwise, you want to be choosing, say, the correct COM port, which will be lit up. But you can also go to a different setting in here. It's not get board info. It is easier with other manufacturers. Anyway, just search for one that you want. And my one is the ESP8266, which I had installed over here. Okay. Now, on the other side, we will have the code that is actually on the Arduino itself. So when it receives a piece of text like M1 forward, it'll do digital write on the pins that are associated with it over here. And the two will work in conjunction with each other. So in the, no, sorry, this one of these is wrong. My mistake. Because I know I have the here we go. Yeah. So I have to delete my Wi-Fi address in there, which you didn't see. But basically, you're hosting the web page here, which is the buttons that you see on the screen. And this would send messages from the ESP to the Arduino. Now, what I did is I took L and I created a new Bluetooth script, or a new Python script. And the Python script basically calls the same piece of information, M2 forward and M3 forward, stopping the other two. And you have the selection between which command you want to choose between. Again, code is available for you below, so you don't have to listen to me ramble on. Here is L, a simple function in L that uses GPT-4o to read an image. And I'm saying, hey, you are a Vision GPT, answer 5 words or less, all lowercase. Is there a girl doll with brown hair? So, oh yeah, I can show you the successful one later. I am looking for, I'm looking for this girl doll, okay? I'm going to get my daughter to hold it, and hopefully the robot can chase her around the house. And so it's like, is there a girl doll with brown hair, large eyes, wearing a dress in the image? And it'll just ask this every few seconds in the main code, so the autonomous robot control, and that's what we're trying to get to. So every 5 seconds, it'll receive an image, send it off to GPT. GPT says yes or no. If it says yes, it goes, well, okay, then I'm just going to drive towards it. And then if I see it 2 times in a row, I'm going to stop driving because it's close enough, right? But if it doesn't see it, it's just going to turn left. And then it'll keep on turning turning right until it gets to see the doll in the image. And it's very simple. Of course, lots of things can be improved. Changing the motors so it can go backwards and forwards, alternating the motors so that they can rotate more quickly like tank tracks, so it can spin on a dime rather than going off in big arcs. Adding more controls for different AI situations, giving it like if-else statements or JSON files worth of information for what it does in lots of different scenarios. Getting the AI to generate outputs that you would find useful, but yet just having the motor control and the vision working. Now, so I also gave the robot this camera. So I'm choosing inside of this code to access the camera 0, camera 0 I think it is, or camera 1. Anyway, it's written here somewhere. So you'll see it when you control F. So it takes the frame, reads the frame, video capture. I don't want the video to be too boring and me looking through my own code again. Anyway, It's in there. You can change it between. I use 0 for my USB camera, which is what's recording the voice right now. I use 1 for using IV cam. IV cam then can be placed up with my phone on the device, and then it's, the ESP connects to my Wi-Fi router, so I set it up so that it's on IP address 192.168.0.208, and that means that if you give it an IP address, by the way, to use, it will start quicker than if you let the router decide where if it should have an IP address on your system. It's just through experimentation I found that it was very important to actually give it an IP address as well and have some fallback and retries. It connects almost immediately right now, and it was causing me a lot of trouble earlier. And I think that's about it. So there's three different types of code. You only need 2 of them. The Python one, you don't need to use the web page, but it's good for testing to see if you've got it working. And then the Python script should run if you've installed all the dependencies that are on the L GitHub page and use requests. And that's it. Now you can go and experiment with making a lot better models and probably explain it in your own YouTube video a lot better than I just did here. Anywho, see you later.